Hello everyone, in this video we are going to learn one of the very important concepts of grade 9, describing motion around us. So we will cover in this chapter the concepts of rest, motion, types of motion, that is uniform motion, non-uniform motion, the concepts of distance and displacement, speed and velocity, acceleration, equations of motion, and few graphs like distance time graph, velocity time graph. Okay, so let's start. First of all, when we talk about rest, what do you mean by rest? A body is said to be at rest if it does not changes its position with respect to a reference point. Okay, and when a body changes its position with respect to a reference point, it is said to be motion. Is it clear? We have basically two types of motion is there: uniform motion and non-uniform motion. Okay, when we talk about uniform motion, okay, it is a type of motion in which a body covers equal distances in equal interval of time. Okay, for example, you can see distance AB is there 100 meter. Okay, person covers in 30 seconds. Another BC distance 100 meter in 30 seconds. Next CD distance of 100 meter in 30 seconds. So if a person or a body covers equal distances in equal interval of time, then it is said to be uniform motion. Whereas non-uniform motion, if a body covers equal distances in unequal interval of time, then it is said to be non-uniform motion. For example, you can see a person is covering A to B 100 meter in 40 seconds, another B to C 100 meter in 50 seconds, another C to D 100 meter in 5 minutes. So body is covering equal distances in unequal interval of time. Okay, or if a body is covering unequal distances in equal interval of time, then also we can say body is said to be non-uniform motion. Is it clear? Next, okay, distance and displacement. When we talk about the distance, it is the actual path covered by the body and it is a scalar quantity, whereas displacement is the shortest path covered by the body and it is a vector quantity. Okay, distance cannot be 0. If a body has travelled, so some distance will be there, it cannot be 0, whereas displacement can be 0. For example, if a body covers in a circular park, okay, so after one revolution, okay, the displacement is what? 0. So we can see the definitions and all. Okay, now you can see, suppose a person is there who has travelled A to B 3 meter, then B to C 4 meter. Okay, so what is the distance? Distance is nothing but AB plus BC, that is a 3 plus 4, that is 7 meter. So when we talk about the displacement, the shortest path from the initial point and the final point is what? AC. It is the shortest path. So that is if this is a right angle triangle, so this is the actually hypotenuse. So if apply the Pythagoras theorem, we can write AC square is equal to AB square plus BC square. If you solve this, AC square will get 25. So AC is equal to what? Square root of 25, which is 4 meter. Is it clear? Next, here one question is there, one numerical is there. A girl moves in a circular park of radius 140 meter. A park is there of radius 140 meter. Okay, this is the radius. So find the distance and displacement covered by her after one revolution. So suppose a person or girl is there, she is starting from here after one round. What is the distance and what is the displacement? So when we talk about the distance, distance is nothing but the circumference of the circle. So what is the circumference of the circle? That is 2 pi r. Solve this. Okay, 2 into pi, pi value is how much? 22 by 7 and radius is given 140. So 7 1 ja 7 2s are, okay, 0 will come. So 2 into 22 into 20. So you will get 880 meter. And what about the displacement? So I started from here and came to here only. Okay, so displacement is 0 only. So displacement is 0. Similarly, they can ask for half revolution. After half revolution, what will be the distance? Circumference by 2. And what about the displacement? This is the displacement right now. That is equal to 2 times of radius. 140 plus 140, that is 280 meter. Is it clear? So like that they can ask you after 1.5 revolution, 2.5 revolution, so you can solve. Okay, now this tricks you should remember. Okay, that will discuss distance, speed and time. Okay, D for distance, S for speed, T for time. If you want to find the distance, so speed into time you have to do. If you want to find the speed, so distance by time you have to do. If you want to find the time, so distance by speed you have to do. Okay, we will discuss. Now, what do you mean by speed? Okay, speed is nothing but distance travelled per unit time. Okay, distance by time is what? Speed. S is equal to D by T. Distance SI unit is meter, time is in second, right now. So SI unit of speed is what? Meter per second. Okay, and the speed is a scalar quantity. It means it has only magnitude, no direction. Okay, so speed is defined as a distance traveled per unit time. You should know how to convert kilometer per hour into meter per second. So 1 kilometer per hour is equal to dash meter per second. So as you know that 1 kilometer is equal to how much? 1000 meter, and 1 hour is equal to how much? 3600 second. We can solve again. So as you know 1 kilometer is how much? 1000 meter, and 1 hour is equal to how much? 3600 second. So 0 cancel. So this is 18 times, this is 5 times. 5 2 is 18 2 is. So how much you are getting? 5 by 18 meter per second. So suppose if you have to convert any kilometer into meter per second, you have to multiply by 5 by 18. For example, 36 kilometer per hour is equal to dash meter per second. So 36 into 5 by 18. So 18 1 is 18 2 is. So 5 2 is 10. Similarly 90 we can solve 25 meter per second. Yes or no? This is very very important because in the numericals, okay, velocity may be given or speed may be given in kilometer per hour. So you must convert into the meter per second, okay, to get the answer in SI unit. Now we talk about average speed. What do you mean by average speed? It is nothing but a total distance traveled by total time taken. Okay, what is this average speed? Total distance traveled by total time taken. Let's take one example. Problem is there, an object travels 16 meter in 4 seconds, then another 16 meter in 2 seconds. So what is the average speed? So use the formula. Average speed is what? Total distance by total time. So total distance is how much? 16 plus 16, that is 32 meter, and total time is how much? 4 plus 2, that is 6. So if you solve this, you will get 5.33 meter per second. This is the textbooks questions only in CRT. Okay, so this I explained. 1 kilometer per hour is equal to how much? 5 by 18 meter per second. So these kind of problems you should practice. 19 kilometer per hour is equal to how much? You have to multiply by 19 into 5 by 18. Similarly 180, 54 we can solve. Okay, vice versa also. 1 meter per second is equal to how much? Kilometer per hour. Okay, so we can solve this also. You can see here. So 1 meter is equal to how much? 1 by 1000 kilometer, and 1 second is equal to how much? 1 by 3600 hour, right now. Yes or no? So what will happen? 3600 will go up and 1000 will come down, right now. So 0 cancel. So 18 times, this is 5 times. So it is how much? 18 by 5 kilometer per hour. Okay, so if you want to find 20 meter per second into kilometer per hour, you have to multiply by 18 by 5. Okay, 20 meter per second is equal to dash kilometer per hour. So 5 1 is 5 4 is 18 4 is 72. Similarly we can solve for 15. We will get 54. Yes or no? Okay. Let's talk about this problem. Okay. Before solving this problem, you should know the 3 equations of motion. There are 3 equations of motion. Okay, what is the 3 equations? You can see first equation is what? V is equal to U plus AT. Okay, second equation of motion is what? AC is equal to UT plus half AT square. Whereas third equation of motion is what? V square is equal to U square plus 2AS. Okay, so what is U? U is the initial velocity. Okay, what is U? Initial velocity. Whereas V is what? Final velocity. T is what? Time. And S is what? Distance traveled. And A is what? Acceleration. Acceleration. So we'll come and discuss this sum. Okay, after discussing acceleration, okay, and velocity. What do you mean by velocity? When we talk about velocity, velocity is nothing but a rate of change of displacement or displacement per unit time. So displacement by time is what? Velocity. Okay, so it is a vector quantity. We are writing vector like this. Okay, so it is what? Displacement by time. So S vector by time, and SI unit is what? Meter per second, and it is a vector quantity. Vector quantity means what? It has magnitude as well as direction. If I say that Syam is moving in his bike with 80 km per hour towards north direction, so that is the velocity. But if I say that Ram is moving in his bike with 60 km per hour, so that is what considered as speed. Speed is a scalar quantity, whereas velocity is a vector quantity. When we mention the direction, it is speed only. What do you mean by instantaneous speed? So velocity of an object at a particular instant of time is called as what? Instantaneous speed. Suppose you are going in a car, okay, with some average velocity, let's say 60 km per hour. So sometimes the velocity will be that 80 km, sometimes 60 km, sometimes 40 km. Yes or no? So suppose you traveled from 9 o'clock to 9:15 am. Okay. So what is the exact velocity at 9:10? Okay. So at any point of time, if you want to know the velocity, that is called as what? Instantaneous velocity. Is it clear? Now when we talk about the average velocity, what is average velocity? It is nothing but initial velocity plus final velocity by 2. Okay. So this is the formula to find the average velocity. So V average is equal to what? U plus V by T. Okay, what is U? U is the initial velocity, V is the final velocity, and by 2. So average velocity, it is defined as the ratio of total displacement of the object to the total time taken. Okay, so V average is what? Total displacement by total time taken. Okay, very important concepts we see. Acceleration. When we talk about acceleration, it is defined as the rate of change in velocity or rate of change of velocity, or we can say mathematically acceleration is equal to what? Change in velocity by change in time. Suppose you are going in a car, okay, and car is moving with a u meter per second. Okay, after some time, after time t, the velocity suppose changes to v meter per second. So we can write acceleration as what? Final velocity minus initial velocity by time. Okay, now, so a is equal to what? V minus u by t. This is the formula. Okay, so where a is what? Acceleration, v is the final velocity, u is the initial velocity, and a is the acceleration. Or we can write a as delta v by delta t, change in velocity by change in time. Okay, here we can see whatever the formulas we have learned and some more extra formula, like a speed is what? Distance by time. What is velocity? Displacement by time. Acceleration, v minus u by t. What is force? Force is nothing but mass into acceleration. Okay, F is equal to what? M into A. What do you mean momentum? P. Momentum is represented as P. That is nothing but product of mass and velocity. M into V is the momentum. Okay, there are three equations you can see. V is equal to u plus at. This is the first equation of motion. AC is equal to what? Ut plus half at square, where AC is the distance traveled, u as I told you, initial velocity, t is the time, a is the acceleration. And third equation is what? V square is equal to u square plus 2as. Okay, this is the distance traveled in nth second, Sn. This is extra formula. Okay, for competitive examinations you can remember Sn is equal to what? U plus a whole into n minus half. So how much is distance traveled in nth second? So Sn is equal to u plus a whole into n minus half. Okay, so u is initial velocity, v is the final velocity, s is the distance traveled, Sn is the distance traveled in nth second. Yes or no? Now distance time graph, the slope of distance time graph gives you what? Speed. How do you find the slope? Suppose this is the graph given. Okay, OB is the graph given. So you have to take any 2 points. Okay, so consider this point A, this point B, and this is C. So if I want to know the slope of this, so this, okay, tan theta is the slope, that is BC by AC. What is the slope? BC by AC is the formula. Or what is BC? This is what? S2 minus S1. See, here to here is what? S2, and here to here is how much? S1, right now. So two different positions are given. Okay, S2, so this is what? S2 minus S1. Similarly, this time is what? T2, and this point is what? T1. Yes or no? So what is this distance? T2 minus T1. So this distance is equal to this distance. So this is also T2 minus T1. So what is this slope? BC by AC. You can remember. Okay, this is a slope is there actually in 10th standard PUC. Slope is nothing but a tan theta. Slope is what? Tan theta. And tan theta is what? Opposite by adjacent. So in this triangle, if you see what is opposite, this is the BC is opposite and adjacent is AC. So we can write BC by AC, that is the slope. So S2 minus S1 by T2 minus T1. So slope will give you the velocity. Velocity is nothing but or a speed, delta S by delta T. Similarly, the slope of distance time graph, velocity time graph give you what? Slope of velocity time graph gives you acceleration. Okay, suppose if the graph is given like this is the time axis, this is the velocity axis. So this is the t versus v. and graph is there like this, you see. Okay, so if you want to know the velocity, okay, so you have to find the slope. Okay, so you have to consider any 2 points. Okay, now so let's say this is this pointer, you see. Okay, so this is what a V1. Okay, and corresponding you can see. Okay, and the time axis you can see this is what a T1. Okay, now similarly for this here the velocity is what a V2, and here what a time is what a T2. Okay, now so this is what a V2. So A, B, C. This is the perpendicular. So what is this velocity? How will find the velocity? Velocity is nothing but a slope of this graph. Okay, slope of this graph OB. So how do you find the slope of OB? That is what a opposite of this triangle. Any triangle you can take. Okay, right angle triangle. So BC by AC. Okay, how we will get BC? This is what V2 and this is what V1. So this distance is what V2 minus V1. So similarly this is what a V2 minus V1 by AC. So this is what V2 minus V1. Okay, now see this is what a T2 and this point is what a T1 right now. So this is what a T2 minus T1. So this similarly this is what a T2 minus T1. So by T2 minus T1. So just now we learnt A is equal to what? Delta V by delta T. This is the slope right now. This is the slope of a velocity time graph give you what a acceleration. In the next video we will work out the numericals based on the, and we will also learn the derivations. Now let's do one numerical which I told we will do this question, you see. I am going to solve also, you can see. Okay, see, check answer the question. This is also textbook questions only. A train starts from rest and attains a velocity of 72 km per hour in 5 minutes. So if any body starts from rest, so initial velocity you have to take what? 0. Okay, first step is what? Initial velocity, that is u is equal to 0. And how much time is given? Time is equal to 5 minutes. So you have to change into SI unit, that is 5 into 60 second, that is 300 second, yes or no? And attains a velocity of how much? 72 km per hour. So final velocity is given how much? 72 km per hour. So we have to change into meter per second right now. How? By multiplying by 5 by 18. So 18 1 ja, 18 4 ja. So we will get a 20 meter per second. Is it clear? So find the acceleration of the train. What is the formula of acceleration? A is equal to V minus U by T. So V is how much? 20, U is 0 and time is how much? 300. Yes or no? So how much? 200 by, sorry, 20 by 300. Yes or no? So this get cancelled. 2 1 ja, 2 15 ja. So acceleration we are getting what? 1 by 15. SI unit will be what? Meter per second square. Is it clear? So that is the acceleration. You can convert it into the fraction also. Now they are asking find the distance traveled by the train during this time. So to find the distance we have to apply the S is equal to ut plus half at square. This is the second equation of motion. So S, as you know that u is 0. So u 0 into t, that is 0 only. Half into a is how much? 1 by 15 into time square. So time is how much? 300. So this is what? 300 square. You solve this. S is equal to what? This will be 0 only, cancelled. So half into 15 into 300 into 300. 300 square we can write 300 into 300. Now we can cancel this one. 150 times right now. So this is how much? 15 3 ja, 45. Yes or no? 45 1230. Yes or no? Into 50. Yes or no? So this is in what? Meter only. This is in meter. So to convert into, this is meter. So convert into kilometer you have to divide by 1000. Okay. So 45,000 divided by 1000 into 15. So 30 will cancel. So 45 into 15 you will get the answer. 5 5 ja 25, balance is 2. 5 4 ja 20 plus 2, 22. Okay, this is 45. So we will get, I think, 675 kilometer. 675 kilometer. Yes or no? And which type of motion does the train undergoes? So which kind of motion it is? It is a non-uniform motion. Yes or no? Because it is starting from 0 and it is attending some speed of 72 km per hour. Okay, na, fine. So this is a rectilinear motion also. Motion in a straight line is also called as rectilinear motion. I hope you understood these concepts. In other videos, we are going to do the derivation of 3 equations of motion. I will take some more graph. If you have understood these concepts, please share this video with your friends. Okay, like the channel and subscribe it. Thank you.